This is a Diamondback Powerline e-bike. It has a Shingy mid-drive motor hooked up to a Dior 1x10 drivetrain with a 34-tooth chainring. This particular bike was a theft recovery that I bought for $500. It came in pretty rough shape. From a distance, it's easy to see all the damage on the paint almost everywhere. The chainstay on the non-drive side is particularly bad. Thief most likely stored this bike outside and let it fall to the ground after every ride. Some other items of note for this bike are that it was supposed to have 27.5-inch rims, but it came with 29-inch rims from a different brand and a 9-speed cassette. The cassette has since been replaced with a proper 10-speed, and I've also replaced the chain, of course. In addition to the paint damage, the display was badly scratched, speedometer wouldn't work, and it had a flashing check engine light, hilariously. This bike retails locally for about $2,000, is rated at 250 watts, and has a 36-volt battery. Upgrades and repairs must be done. Here we have the motor. It is a Shingy CMT-01N. I have replaced the motor controller with an L1019 connector. It's hooked up to a GRIN base runner on a 48-volt battery, which is an upgrade. And as you can see, I've got that hooked up all to a cycle analyst. Everything works, including speedometer and pedal assist. Here's the inside of the Shingy CMT-01N motor. As you can see, I've popped off the motor controller so I can replace it with an external controller. Here is the hall sensor board, really easy to work with, really easy to not break. Here's the torque sensor. It has one wire for cadence and one wire for torque, which I was able to figure out using a multimeter. The torque sensor requires 5 volts, but the cycle analyst provides 10 volts, so I have inlined a 10 volt to 5 volt DC converter. Upon hooking up the torque sensor to the cycle analyst, I can see that it does 1 volts to 2 volts. As I wrench down on the pedal, you can see that it maxes out at 2 volts. I've set it to 100 newton meters per volt. Understanding the gear reduction, we have 8 teeth here to start, and it is a primary planetary reduction. The sun gear is 64 teeth, and it drives off of the carrier to a 1:9 reduction ratio. We have a 25 tooth out of that, and then an 80 tooth here, so an additional 3.2 reduction ratio. With the motor open, it is easy to count the magnets. There are 16 magnets, or 8 pole pairs. If we times that by the primary reduction ratio of 9:1, we're going to have 72 pole pairs, which is going to be an important component when programming the motor controller. To enhance the capabilities of this motor, I have epoxied a thermistor here on the motor stator. This will allow me to monitor the temperature and perhaps push more power through it. I had to replace the wheel speed sensor with one off of AliExpress. It runs off of 5 volts and it works perfect now. With appropriate wheel circumference, it reports accurately. And now I have my my wire here, which has, again, my MT60. We've got the Hall wires here. This 2-pin one is the thermistor, and then this is going to be pedal assist, this 3-pin one. I was unable to use auto tune to configure this motor and motor controller using the phase runner suite. It just wouldn't pick up the Hall pattern. Eventually, I loaded up a Shingy SX motor map from GRIN and modified that to get it to work. This motor has a relatively small stator and light gauge phase wires, so I've opted to use 50 amps of max phase current as to not destroy it. This is the first attempt at getting it to work, and everything is mostly working. I had originally connected the L1019 cable to the motor using the MT60 and JSTs that you see here, but unfortunately it just didn't fit in the bike very well. The holes to route the wire through were too small, and the gaps once you try to put the motor in are also just very small, and it's hard to pack it back up. I'm not too worried about the L1019 being hardwired into this motor, given that the L1019 connector itself is actually very modular and designed to hook up to almost any motor controller. So I'm pretty satisfied with the outcome. And here it is working with throttle. I lifted the rear wheel, give it a spin, and it sounds pretty good. And here's a quick test of the torque sensing pedal assist. I'm using the rear brake to provide resistance, and I'm pedaling with my hand. You can hear the motor spin up as I rotate. You can also see the functioning speedometer here. Everything is working great. time to take it out on the road. Just before I head out, I'm going to pop on this 50-tooth sprocket, see what kind of top speed we can get. .50 km/h top speed. Not bad. Thanks for watching. Stay tuned for more updates on this bike.